Okay, hello class. So today we'll be doing the Bode plot study, okay, on learning how to draw Bode plots. So this is a recording of how to draw Bode plots for your examination to come. Okay, so for Bode plots, you need your highlighters, okay, get about 2 colored highlighters. You can choose whatever color you want to use. Okay, now we need a pencil for Bode plot. You're not going to draw a pen, okay, so you need the pen as well, okay, and your ruler. Alright, make sure one end of it is transparent, okay, and you need the eraser as well to erase whatever you made mistakes in your Bode plot. Alright, so this is your Bode plot paper over here, okay, make sure it's in this position where you have from the big square all the way down to the smaller squares, like this, in this order, okay, it's in logarithmic order. Alright, so let's start today's Bode plot example. Okay, given that you have the transfer function gs equals to 10 over s plus 0.2 and s plus 50. Okay, now when you have a transfer function like this, what you need to do next is you need to take out and you need to write it in this form. Alright, now you need to put everything in a static gain of 1. So in this case, if this is 0.2, you need to multiply the top also by 0.2. Okay, same goes for the 50. Now, as you multiply the top by 0.2, okay, you must divide it here by 0.2 as well. And you must divide the bottom by 50 as well. So that when you multiply back this whole function over here, you will still get back this transfer function. Okay, whatever you give, you must take as well. Alright, so once you get it in this form, alright, so the next thing you need to do, you need to calculate this part over here, where if you calculate this, okay, you will have 10 over 10, okay, alright, 0.2 times 50 is given as 10, this one will give you 1. Therefore, the next thing you need to do is you need to find the constant gain k. Okay, let's put it as k1 now. Alright, constant gain k1, which will equal to 20 log of 1 over here. 20 log of 1. Now you take log of 1 will give you 0. Okay, therefore this will give you 0. So your constant gain for this question will give you a 0. Now you need to determine the range of your Bode plot for your phase diagram. Okay, so to determine the range, it will be what, 90, okay, times np minus nz, where you have 90, np number of poles you have 3, so therefore nz will be give you 0, there's no zeros, therefore this will give you 270 degrees. That means your Bode plot will end at 270 degrees for your phase diagram. Okay, got it? So next, we'll move on to drawing your Bode plot. Okay. So you need to draw the Bode plot, okay, for GS, over here, GS equals to 10 over 0.2 times 50 times 1 over S times 0.2 over S plus 0.2 times 50 over S plus 50. Okay, so you need to start out by drawing the constant one first, okay, the constant, then the integrator, then the 2 first order numerators. Okay, so let's start with writing the range for your Bode plot. So start by writing the range here. So you start out at the range of 10 to the power negative 3, follow on by 10 to the power negative 2, 10 to the power negative 1, 10 to the power 0, 10 to the power 1, 10 to the power 2, and 10 to the power 3. Okay, so next, now it ends at the range of negative 270 degrees, therefore here will be negative 270 degrees. Okay, now you count 2 blocks up will give you negative 180 degrees, 2 blocks up again negative 90 degrees. Alright, 2 blocks up will give you 0, and up here will give you 90 degrees. Okay, now we need to draw the gain plot as well. So let's start with the gain of 60 decibels. Okay, followed 2 blocks down will give you 40 decibels. Okay, and here will give you 20, 0, negative 20, and negative 40. Okay, all these are for your gain plot, which is in decibels, and this is in degrees. Okay, so now let's start to draw your Bode plot. Now this part over here will give you your constant gain K, alright, which just now we calculated, when K 20 times log of 1, which is over here, will give you 0. Therefore, you take a pencil, okay, and then you draw a straight line over here at 0. Okay, draw a straight line over here at 0. So this is your constant gain K. Alright, make sure you label your plots. This is your K1, okay, your constant gain of K1. Alright, so next, okay, you need to draw your integrator. Okay, so your integrator starts from 1. Okay, remember it starts from 1, so let's mark a 1 over here. Let's mark a x at 10 to the power 0, which is 1. Okay, now your integrator goes down, right? So it goes down from 0.1 times of 1, which is here, and 10 times of 1, which is here. Okay, so 10 times of 1, you go to negative 20 dB. Okay, and you draw a straight line across over here. So the integrator, it goes from negative 20 to negative 20 dB, from 0.1 to 10. Okay, so it goes all the way up over here and down over here. One straight line over here. Okay, alright, crossing the point of 1. So this is 0.1 and this will be your 10. Okay, your omega equals to 1, 0.1 and 10. So this is how your integrator diagram looks like. Okay, now always remember to label your plots. Okay, so this will give you, label it to be 1 over S. Okay, now we need to draw your first order numerators. Okay, so this one starts at 0.2. So let's say 0.2 here will be your A. Okay, 0.2 here will be your A. So find the point of 0.2. So given here is 0.2, mark a X over there. Okay, now 0.2 will be your A, so 0.1 times of your A will be here, and 10 times your A will be here. Am I right? Okay, now for first order numerators, you need to start from 0.2, which is your A. Okay, alright, so from 0.1 times A to A will give you a 0 dB line. Okay, it will give you a 0 dB line. But from A to 10 times of A, it will be a slope of negative 20 dB going downwards like this. So here will be negative 20 dB, and you go all the way down like this. Okay, be a slope of negative 20 dB going down like this. Okay, from 0.2, okay, all the way to 10 times of 0.2. Okay, so mark this, always label your Bode plots. Okay, so this will be 0.2 over S plus 0.2. Okay, now next you need to do for your last first order numerator. So we have 50 over here, so here 50 here will be your A. Okay, therefore you look on your Bode plot diagram, look for 50. Okay, so here is 10, 20, 30, 40, 50. So here will be 50. Okay, here will be 50. So look for 0.1 times 50, which will be here. 1, 2, 3, 4, 5. 0.1 times of 50 will give you 5. And 10 times of 50 will give you 500, right? So this will be 100, 200, 300, 400, and 500. So same thing for your 0.2 plot just now. Okay, so from 5 to 50 will give you a straight line over here. Alright, we'll give you a straight line all the way across. Okay, and from 50 to 500 over here will also give you a slope of 20 decibels downwards. Okay, so then you mark this line to be 50 over S plus 50. Are we clear? Okay, so now you have drawn all the plots, okay, from your K1 alright, we have K1, your integrator, your first order numerator, and your last first order numerator. So we have done all the drawing of lines for all these Bode plots, for all these transfer functions over here. So now we need to combine them to give us the Bode plot of your total Bode plot of your GS over here. So how to combine them? Okay, now let's start from here. So when we combine two gain plots together, it is a sum of logarithmic terms. Therefore, if this were to sum with your K over here, this will be given as the same line coming down here. Am I right? Because this gain times plus with your 0 over here, 0 dB, 60 plus 0 dB will still give you 0. Am I right? So therefore, it goes all the way down here. Now until this point here, okay? Now until this point over here, alright? Can you see there's now two gain plots coming downwards like this? Okay? This will give us a slope of negative 20 dB going down. And this one will also give us a slope of negative 20 dB coming downwards. Okay? So initially it is coming down from here. Okay, initially it's coming down all the way from here to here, and then it puts a stop here. Alright, because now this point here will be where it starts to change its gain plot. Now from here, okay, mark a spot over here, probably you can mark a cross. Okay, now starting from here, now this will stop at a point of 0.2. Okay, now go 1 decade away from 0.2, which is 10 points away. 10 times of this point will give us a 0.2 point over here. Am I right? 10 times away will give us 0.2, a decade away. Alright, so here you mark a spot of X over here. Alright, now to go down to 20 dBs, okay, to go down 20 dBs, you need to calculate how many cms will give you 20 dB. So in this case, my ruler will give me 1.8 cm to give me 20 dB. So if 1.8 cm over here gives me 20 dB, alright, so I want to find how much will it go down, alright, okay, 1.8 cm will give me 20 dBs, therefore, for 40 dBs, alright, this will give me 40, right, negative 20 plus negative 20 will give me 40. So 40 dBs, okay, now we need to calculate 40 dBs over here. So 40 dBs is 20, 40, which will give me, what, 3.6 centimeters. About 3.6 centimeters to give me 40 dB. Therefore, I put my ruler over here. I find 3.6 cm over here approximately. Alright, so this will be 3.6 cm. Alright, and I draw a line from here, the cross point here, to this 3.6 cm cross over here, coming down. Okay. Alright, okay, because this now comes down from this point onward, it comes down by 40 decibels. This is negative 20, this is negative 20. Okay, so we come all the way down here, alright, by 40 decibels. Okay, and then it stops right at this point here. Okay, right at this point here at 50. Because from this point onwards, its gain starts to change. So you draw another cross point here. Okay, now find the 1 decade away from this point, which is, this point is 2, 3, 4, 5. So 1 decade away will be 500, right? So let's find 2, 3, 4, 5. 2, 3, 4, 5. So this is the point that we will change the plot. Alright, so this is 500. Alright, okay. So we now we have negative 20 going down. So total now is negative 40, right? So here is also going down by another 20 decibels, which is negative 20 going down as well. So negative 20 plus negative 20 plus negative 20 will give us what? Negative 60, right? So you find the centimeters that will lead to 60 decibels. So in this case, 5.4, about approximately 5.4 will give me 60 decibels. So therefore, from this point onwards, I have to find 5.4 downwards, okay, 5.4 centimeters, and then I draw my line from here all the way crossing this 5.4 cm over here. Okay, so now you have to darken all the lines that you have drawn. Okay, so you darken it. Alright, darken it to indicate this is your final plot of your line. Okay, and next you use your highlighter and you draw your final gain plot. Okay, draw your final gain plot. Alright, and you use your pen to mark that this is your final gain plot GS. Okay, so this will be your gain plot of your transfer function over here. This will be your gain plot of your transfer function GS. Okay, alright, are we clear on looking for gain plots? Now next we'll be doing, alright, your phase diagram plot. Okay, your phase diagram plot. Now your constant, okay, your constant will not give you any phase, therefore your constant is just it just gives you 0 phase over here. Okay, constants will not give you any phase, so you draw a 0 line at your phase diagram at the bottom here. Alright, so the bottom here onwards will be your phase diagram. Okay, now your integrator will give you a negative 90 phase. A negative 90 phase, therefore you draw a negative 90 line. Okay, a line at negative 90, just a straight line across negative 90. Okay, so then you mark with your pen that this will give you that this will be your 1 over S phase. Okay, your 1 over S phase. Alright. Now for your first order numerators, okay, the way you draw your phase will be almost the same as how you draw your gain. Alright, so let's go and mark the point. Now this is 0.2, so the point of 0.2 will be here. Okay, now 0.1 times the 0.2 will give us 0.02. Okay, 0.02, which is here, 0.02, and 2 will give us a plot here. 10 times of 0.2 will be here. So now for your phase plot, okay, alright, it will go down at negative 45 decibels per decade. Therefore you start off from point 0.02, which is 0.1 times A, all the way to 2 over here. So you will draw a straight line down, and this will mark at negative 90 degrees over here. So this will be from 0.2 to 2, which is 0.1 A to 10 times of A. You draw a negative dB slope over here, negative 90 dB slope going down over here. Alright, this will indicate that it is going down at negative 45 degrees per decade, where this decade to this decade will give us negative 45 degrees. This decade to this decade will give us negative 45 degrees. So this will be what? Negative 90 degrees per 2 decades. Alright, so next we draw also for your first order numerator for 50. So we go to find the point of 50. 2, 3, 4, 5 over here will give us 50. 10 times of 50 will be 2, 3, 4, 5 over here, and 2, 3, 4, 5 over here will give us 5. So same thing from 5 to 500, which is 0.1 A to 10 times of A. You draw a slope line coming down at negative 90 degrees. Okay, negative 90 degrees of phase. Right, so now we have this over here. Okay, so the next thing we need to do is we need to combine all the phase diagrams together. Okay, so to combine them, alright, it'll be the same way as we combine the gain plot. Okay, so this starts at negative 90, so therefore negative 90 plus 0 will give us negative 90 line over here. Now we stop over here because coming down onwards from here will be of different phase, correct? So from here to point here, it is coming down at a phase of negative 90, negative 45 decibels. Okay, so we draw a line coming down here like that. Okay, all right, so coming on here, we have no gain over here. All right, no gain, so we just draw a straight line over here. No gain difference, so we draw a straight line over here. Sorry, not no gain, no phase difference, therefore we draw a straight line over here. Okay, now from here onwards all the way to 500, the omega equals to 500 over here, there is a drop in negative 45 decibels per decade. So therefore, from this point onwards, all the way to this point over here, which is 500, omega equals to 500, it is coming down again by negative 45 degrees per decade. So you draw a line coming down over here, and therefore at the end over here is just a straight line. There's no phase difference. Therefore, we just draw a straight line ending over here. Alright, so then we take our second highlighter color. Alright, so we highlight our phase diagram. So our phase diagram, we highlight it here, and this will be our phase plot. Okay, and we use our pen to label the plot. So this will be a plot of 50 over S plus 50. This will be 0.2 S plus 0.2, and this whole gain over here will be GS. Okay, alright, so now we have our gain plot and our phase plot for our transfer function. Alright, so once you get your phase plot and your gain plot for your transfer function, you need to find your gain margin and your phase margin. Alright, your gain margin and your phase margin. So to find your gain margin, okay, you find the point that it crosses 180 degrees over here. Alright, 180 degrees over here, which is from omega equals to 2 to omega equals to 5, right? So in this case, if it's just one straight line like this and it goes down, alright, we take the in-between of it, okay? We take somewhere in the center of it, which is over here. We have the center somewhere around maybe over here, about 0.8 or 0.7 cm. Okay, you find the center point over here, alright, because it's just one straight line. Okay, but in other cases, if you just cross, you find the point of intersection. So in this case, this we assume it to be the point of intersection. So from here, okay, put your ruler straight at this line over here, look up. Okay, now this one, look up, it touches your gain plot over here and it goes up here. Alright, it goes up here. So this line over here, alright, will indicate as you bring your gain plot up. Okay, if you have to bring your gain plot up, this will give you your positive gain margin. This will give you a positive gain margin. Okay, it will give you a positive gain margin, where if you calculate your gain margin, alright, so you measure, okay, how long would this line be? So let's say you measure this line to be approximately about 3 centimeters. Okay, alright, 3 centimeters. Now as 3 centimeters, you want to know what's the gain, but you know 3.6 centimeters will give you 40 decibels. Therefore, if you calculate this, alright, it should give you, let's say, it should give you about, now let's say you calculate, so you have 3 times 40 divided by 3.6. So this will give you about 3.33 decibels, 33.33 decibels. Alright, so your gain margin over here, your GM, will give you 33.33 decibels. Okay, positive. Alright, now to find your phase margin, you need to find the point where you need to find on the gain plot the point where it intersects 0. Okay, the point where it intersects 0, where is this point over here? Okay, where is this point? It intersects 0, and you go all the way down. Okay, all the way down, and this will be your gain margin over here, phase margin, sorry, over here. Okay, so you measure, okay, what is this line going to be? Okay, now if you have to bring down your phase margin, okay, this line of your phase margin will be the point where from this line over here, okay, the point of intersection of 0, you go all the way down. Okay, you see your phase margin plot, you draw a line all the way to the point, the line of 180 degrees. Okay, the line of 180 degrees. This difference, okay, this difference will give you your positive phase margin. Okay, this difference will give you your positive phase margin. Alright, positive phase margin. Alright, so let's measure the line over here. Okay, this one will give us about, let's say 0.6 about 0.6 centimeters. Alright, so if 0.6 centimeters, we want to find what's the phase. Okay, we want to find x. Now we know that 0.8 centimeters, okay, alright, or let's not put it. Let's say we know 1.8 centimeters will give us 90 degrees. So let's count what will give us for 0.6. So 90 times 0.6 divided by 1.8. So this will give us 30 degrees in phase margin. So your phase margin over here will give you 30 degrees. Alright, so this is how you find your gain margin and your phase margin over here. Alright, this will tell you how you find your gain margin and phase margin. So you need to know how to draw your Bode plot first in order to find your gain margin and phase margin. And from here, you can tally with MATLAB to see whether your answers are correct or not. And your MATLAB example, I will show you after this recorded lecture. Okay, thank you very much, and we will try another example in a short while. Alright, thank you.